Have you ever wondered why NASA doesn't launch their rockets in poor weather, specifically around lightning storms? Well, that's because back in the 1960s, they did, and things went a bit south. So, let's talk about that. It's November 1969, and NASA is getting ready to launch their Apollo 12 mission to the moon. Only problem is, it's raining. While this is definitely less than ideal for the spectators, which include Richard Nixon, the current president of the United States, this weather doesn't violate any of NASA's launch commit criteria, so they go ahead and launch the rocket despite the less than ideal weather. At 36 seconds into flight, that decision came back to bite them. All three fuel cells powering the Apollo command module detected an overload and went offline. And then, at 52 seconds into flight, the attitude indicator also went offline. So, what happened? Lightning. The Apollo spacecraft and Saturn V rocket got hit by lightning not once, but twice, less than a minute into flight. This threw the entire system into chaos. The entire command module was essentially dead, and without it, they can't go to the moon, and they are looking at an abort scenario. Luckily, two decisions made more than a year before the flight ended up saving the mission. The first of these decisions was made while designing the Saturn V. So, let's jump on into Kerbal Space Program, where I have one that we can take apart and understand what this decision was. So here we are in Kerbal Space Program with the Apollo spacecraft. The Apollo spacecraft consisted of the Launch Escape Tower, the Command Module, the Service Module, the Lunar Module, and the Lunar Module Adapter, which mounted the Service Module, the Lunar Module, and the Command Module to the Saturn V rocket. The Saturn V is sitting right over here, and it was a very unique vehicle when it was being designed. This was one of the first rockets in history, and the first one used by NASA, that was being designed from the ground up to carry a crew. Before this, all the rockets NASA had used were converted nuclear missiles. As they were nuclear missiles, they all had their own guidance system on board from the very beginning. But now, NASA was designing a rocket that would carry a spacecraft that had its own guidance system. So, the idea was floated around of having the entire launch controlled by the Apollo spacecraft. But, they decided against it. Instead, the entire Saturn V vehicle is controlled by a small ring of computer units. This whole unit is called the instrumentation unit, or instrumentation ring. This tiny piece of equipment, or not really tiny, this piece of equipment controlled the entire Saturn V moon rocket during ascent, and the Apollo spacecraft was just a passenger. This saved Apollo 12 in that while the electrical system on the command and service module was dead from the electrical strike, the service or the instrumentation unit on the Saturn V was perfectly fine and kept flying the rocket into orbit as it was intended to. If that had been damaged, or if it had been omitted from the design altogether and the launch was guided by the spacecraft, the entire mission would have been aborted the instant the lightning strike occurred. But because the engineers had decided to include this instrument unit, the launch kept going and they were able to save the mission. The second decision that saved this mission was the decision to run a simulator test over a year earlier. In this test, a power supply malfunctioned and gave off a very unique set of data. This data was seen by John Aaron, who would be present on mission control a year later during the Apollo 12 launch. Recognizing this data, he remembered that there was a switch in the Apollo command module that could fix the problem. This switch, labeled SCE to aux, or Signal Conditioning Electronics to Auxiliary, would switch the signal conditioning electronics from their primary power supply to their backup power supply. Unfortunately, this was a very, very obscure switch. So when he gave the command to the flight director saying, hey, try this switch, it might fix the problem, the flight director had no clue what he was talking about. So John Aaron repeated it, and the flight director forwarded the command to Capcom, who also said, what the heck is that? Nevertheless, he forwarded it onto the crew, who also said, what the heck is that? But luckily, Alan Bean knew where the switch was. In that simulator test a year earlier, Alan Bean had used that switch to fix that problem. So not only did John Aaron know that that switch would fix the problem, but Alan Bean knew where the switch was. So between the two of them remembering things they had learned from that test, they knew both exactly how to save the mission. And they did. With the power supply back online, they were able to sort out all the other little electrical problems on the mission, and the mission went off as planned. The mission went and landed on the moon and came back safely. This whole mission would have been aborted before the first stage even separated had John Aaron and Alan Bean not known about that tiny little switch in the command module. This is one of my favorite stories from the Apollo program, as it shows off how quick thinking and running tests and how one really smart engineer who knows what he's doing can save an entire mission. After this, John Aaron was known as a steely-eyed missile man and is one of the most well-known engineers in the Apollo program's mission control. So with that, that's the end of this video. I hope you enjoyed watching this video as much as I enjoyed making it. If this is your first time watching one of my videos, I invite you to go check out my other videos on this channel, and if you like what you see, I invite you to subscribe. With that, I want to remind you guys that my videos come out every Thursday at 7 p.m, so keep an eye out for those in the future, and thank you for watching my videos. See you next time.